Hello, everybody. I'm Mike. I'm going to go through the flight scenario number 3. And so we are a commercial student. We're working on our cross-country flight, and we notice that there is a discrepancy in the time between our two checkpoints. So the biggest discrepancies are going to be what we planned based on estimated data and what's actual. And what's actual is how our airplane feels in the air at that very moment, which is not a constant thing. It's not flying through the same density air. It's not flying through the same pressure, and it's not flying in the same temperature. And all of those have a drastic change on the altitude that we're flying. And because all of those change density, and density inversely is related to our pressure altitude, when we're flying along at a set altimeter setting on an IFR flight plan for a cross country, um, we're not going to be flying at the true altitude that we had planned with our winds and our temperature and everything like that for our fuel burn and our airspeeds. So what's happening? So we have our IFR set given altimeter setting, ATC gives us. And if they give you that altimeter setting, you put it in, you're flying along. Well, you're not flying that altitude, you're flying that isobar. And they do that because it's going to give them aircraft separation. So when you have a change in altitude and you're not flying the altitude that you had planned, you have a little bit of change in the drag and performance of your aircraft. Maybe you're not flying at the recommended altitude versus engine output and attitude to give you the best performance. So when you're flying the mnemonic and you're going from low to high, we learned in IFR training, you are going low to high, clear the sky, right? So you're actually going to be flying higher than indicated. And we know this because when we look at um, the change in our altimeter, if you're flying and it's you leave from 2942 and you go to 2992, you can take that difference of 0.5 multiplied by 1,000, and we get a 500-foot change in our actual altitude based on what's indicated. And so, so when we're flying that constant isobar, we're actually 500-foot difference. And 500-foot difference, we know from our landing and our performance charts, can be up to 100 foot on our ground roll. So that same effect of drag in the air also changes our airspeed and our performance of our aircraft, which really leads me into the next point is a lot of our planning happens with interpolating charts under standard or between standard or non-standard, basically, between standard temperatures, and you have different sea level pressures, but it's not always like that. And hardly ever will you find an airport that's at standard pressure up to higher altitudes. At low altitudes, it's pretty constant for your altimeter to get to 1 inch per 1,000 feet, but beyond the low altitudes, it really changes at different rates. It's not standard. And so those differences have a big effect on the weather that you're flying through. So basically, you're flying through a fluid in the air, and that density of that fluid is dependent on the temperature or the pressure around it. So if you're flying at a wrong pressure, or you're flying from a hot to a cold, or a cold to a hot, or a high pressure to a low pressure, which is constant because all the air around us is changing at every given moment, you're flying at different densities. You're flying over large mountain ranges. You're flying through fronts. You're flying over major terrain features, and all of those will give you a very drastic change in pressure. And so when you get that drastic change in pressure, you get a drastic change in density as well. And those are all going to affect the time in between your checkpoints, which is your density, the air that you're flying through. So what can we do to improve that data? Well, you did your planning as effectively as you can, but you can update your altimeter setting and try to fly that actual altitude the best you can. But legally for VFR, you only have to update it every 100 miles. Well, some cross-country flights are only 100 miles, so you only have to update it at your destination legally. So everything in between that, you could be flying a constant isobar rather than a constant altitude. And depending on those changes is depending on your performance factors. When you're flying IFR, you're just flying that same constant isobar for VFR separation. So you might not even be the level that you're trying to get. So the difference in your planned true airspeed and your actual true airspeed is going to determine the biggest changes in your weather. You could also pay attention to the weather changes that are happening below you. If you're getting very gusty winds across the surface and you're going from a gusty to a calm wind, you know that there's going to be a pressure change relative to that, because pressure wind is a product of the pressure. So you know that you're flying through you're flying through weather that's changing dramatically. Anytime that you're flying through higher density, you're going to also have increased drag, and those are going to affect the performance of the airplane as well. So as you're flying through and you're going from checkpoint to checkpoint, and remember, you're not flying the constant altitude, constant wind speed from A, B, C, D, or 1, 2, 3, and 4. You're flying through a constant fluid that's changing at all times. It's changing wind direction, speed, and you're changing altitude or true altitude along the way. So if you get close to your performance factors, it's probably because you're at standard conditions. But if you're not, which is more than likely, then it's because you're at non-standard conditions.